Hello, today I will be presenting my results for Physics 2212 Lab 4 on circuits. So the goals of this experiment are to create a physical series and parallel RC loop, assess the loop rule, charge conservation using multimeter measurements, and compare experimental and calculated values. The results are the node and loop rules are safely proven. Increases in resistance caused increased capacitor charging time, and the calculated RC value from circuit 3 was 42.854 seconds. So a couple of key concepts are steady state circuits, which have a constant flow of current, constant charge drift speed, and a constant non-zero E field inside the conducting wire. The loop rule says that the difference in potential in any closed loop in a circuit is zero. The node rule says that the current entering a junction must equal the sum of currents exiting the junction. Ohmic resistance measures the opposition of flow of a current in a circuit, measured in ohms. Capacitance measures the of charge accumulation. And then here is a picture comparing series and parallel circuits. So for this experiment, the system is the circuit, including the lights, battery, wires, and capacitors. The surroundings are everything else. The provided materials are two 1.5 volt batteries, light bulbs, multimeter, 47 and 100 ohm resistors, and a 200 mF capacitor, and wires. Potential errors are faulty wiring, weak batteries, and slight internal resistance from the batteries. So for circuit 1, the calculated and expected current value is 0.0204 amps, and the measured was 0.01 amps, which is evidence of charge conservation since it measured the same at both measurements, but the lower amp measurement than expected is not normal. So here are the expected potential differences for the 47 ohm resistor. It is negative 0.959 volts, and for the 100 ohm resistor it is negative 2.041 volts. The actual potential differences were negative 0.987 volts and negative 2.111 volts, respectively. The measurements were off but close, which is evidence of the loop rule. This is a graph that just shows or visualizes the first circuit. So for RC circuit, the light bulb started on and was bright and then began dimming slowly until it was completely off. The dimming was caused by the charging of the capacitor in the circuit, and then discharging. When batteries are removed, the light begins dimming again. So the charge and discharge times for the circuit without the resistor in series, we have 15.7 seconds and then 12.8 seconds. And then for the charge and discharge times with resistor in series, this time the charging time was 62.45 seconds and the discharge time was 71.01 seconds. The charge and discharge times were similar for each circuit, and the longer charging and discharge times for series with more resistance. Finally, we had the capacitor circuit, and the computed RC was 42.854 seconds, which was similar to the LE value of the real circuit's original value previously recorded at 33.5 seconds. So what if you were doing this lab in real life and used an actual ammeter instead of an ideal simulated ammeter? A real ammeter experienced slight internal resistance like the batteries, which would lead to a similar small decrease in current. What if you were doing this lab in real life and used a real battery to charge a real capacitor with no resistors in the circuit? The real capacitor takes longer to charge as real wires have slight resistance, and for the same reason using a real ammeter would increase charging time. Thank you.